Have you ever stopped to think that every star in the sky, every grain of sand on Earth, and even you, yes, yourself, are all made of stardust, forged in the furnaces of the early universe? This is the legacy of the Big Bang, the beginning of everything, but not in the way many imagine. Many think of the Big Bang as a gigantic explosion in space, with stars and galaxies flying out from a center. However, the Big Bang was not an explosion in space. It was the expansion of space-time itself. Imagine a balloon being inflated. Every point on the surface of the balloon moves away from every other point as the balloon expands. This is how the universe expands, with entire galaxies moving away from each other, navigating the fabric of space that is constantly stretching. In the first moments after the Big Bang, the universe was not the vast, dark space dotted with stars that we see today, but a force of subatomic particles colliding at unimaginable speeds. It was against this backdrop of primordial chaos that the building blocks of the universe, such as hydrogen and helium, began to form. Imagine the complexity of everything around you, from a drop of water to the air we breathe, began with these simple elements in the first 20 minutes of the universe's existence. This is the incomprehensible power of primordial nucleosynthesis, the first and most fundamental alchemical kitchen in the cosmos. But what exactly is what we know as primordial nucleosynthesis? It is the process by which the nuclei of the first elements were forged in the extreme conditions of the young universe. The laws of physics mixed protons and neutrons to create the basic menu of the universe: 75% hydrogen, 25% helium, with a sprinkling of lighter elements such as lithium and beryllium. These are the concrete proof that supports the theory of how our universe began. The proportion of these elements is so precise that if it were slightly different, our universe would be a very different place, perhaps even incapable of sustaining life as we know it. Imagine that the universe is like a balloon which, just after it has started to inflate, the Big Bang, suddenly starts to expand at an incredibly high speed, much faster than at the beginning. This extra fast puff is what we call cosmic inflation. It happened for a very short time right after the universe was born, but it was enough to change everything. To understand it better, think of a piece of pizza dough being stretched. Initially, there may be some bubbles or irregularities in the dough, but as you stretch it, these bubbles spread out and become less noticeable. The universe, just after the Big Bang, was like this pizza dough full of bubbles or irregularities. Cosmic inflation was the process of stretching this dough rapidly, making the universe more uniform and smooth. Imagine that instead of just using your hands to stretch the dough, you have a special tool that makes it expand faster than it normally would. This superblow in the balloon of the universe solved some puzzles that scientists had about how the universe is so uniform on a large scale, despite having started out so chaotically. Imagine you're in a dark room and suddenly a ball of glitter explodes, illuminating everything for a brief moment before disappearing. Even after the light goes out, particles of glitter float around the room, covering every corner. This floating glitter is like the cosmic background radiation, CBR, of the universe, a luminous remnant left over from the great explosion that started it all, the Big Bang. RCF is a kind of invisible light that we can't see with our eyes, but which is everywhere in space, filling the universe with a glow that is the echo of that initial explosion. Now imagine that you have a special camera that can capture and show where every particle of glitter is in the room. When you take a picture, you not only see the glitter, but also how it is scattered around, revealing patterns and shapes. Scientists have something similar with this special camera, an advanced technology that allows them to photograph cosmic background radiation. These photos are like maps showing how this ancient light is distributed throughout space. And the amazing thing is that these patterns tell stories about how the universe has expanded and evolved since that first bright moment. By studying these RCF maps, scientists can confirm that the Big Bang really happened and better understand the structure of the universe on a large scale. It's as if, by looking at the pattern left by the glitter, we can reconstruct the initial explosion and everything that happened afterwards. Thanks to this ancient light and the tools we have to study it, we can look back to the beginning of time and see the origins of the cosmos. Edwin Hubble discovered in the 1920s, using nothing more than the light from distant galaxies, that the ground beneath your feet, the sky above you, and even the distant stars are all moving at the same time. With a telescope pointed at the sky, he not only observed the universe, but also saw into the past, revealing that the galaxies are moving away from each other. It's as if every star, every planet, every piece of matter is on an immense fabric being stretched, causing everything to slowly move apart. This moment was so revolutionary that it changed our understanding of the cosmos forever, proving that the universe is much more dynamic than we ever imagined. What if I told you that there was a cosmic ruler capable of measuring this distance? This is the essence of Hubble's law, a simple but powerful equation that allows us to calculate the speed at which galaxies move apart based on their distance from us. The further away a galaxy is, the faster it seems to be moving. This not only proves that the universe is expanding, but also gives us clues as to how it all began. The Hubble constant, which has been refined over the years through increasingly precise observations, plays a crucial role in determining the age of the universe and understanding its rate of expansion. Now imagine that the universe is like a giant jigsaw puzzle. As you put it together, you realize that some pieces are missing, but somehow you know they exist because the drawing wouldn't make sense without them. This is the role of dark matter and dark energy in the universe. Dark matter is like the invisible pieces of this puzzle. We can't see them directly, but we know they're there because without them, the parts of the puzzle we can see, the galaxies and galaxy clusters, wouldn't hang together. Imagine you have a string of pearls. If you don't have the string, the pearls will scatter. In the universe, dark matter is this invisible thread that holds the pearls, galaxies, together by gravity. Without dark matter, galaxies would fly away from each other because visible gravity would not be enough to hold them together. On the other hand, dark energy is like a mysterious force that is pushing the pieces of the puzzle away from each other, accelerating the expansion of the universe. Imagine that, instead of trying to assemble the puzzle on a table, you are doing it on a surface that is expanding. The more you try to put the pieces together, the more the surface extends, making the job increasingly difficult. Dark energy is that force that makes space expand, which is why, even though gravity tries to pull galaxies closer together, the universe as a whole keeps expanding faster and faster. The Big Bang tells us about the beginning of everything, but also about human nature, about our endless search for answers, and our desire to understand the grand stage on which we play our ephemeral roles. If you're fascinated, curious, or even skeptical, join us. Subscribe to the channel, give us a like if you like what you've learned today, and share your questions or the mysteries of the universe you'd like to explore in future videos. The universe is a gigantic puzzle, and together we can begin to unravel its secrets, one video at a time. Be sure to comment on what intrigues you, because your curiosity is the spark that can illuminate the next great mystery we're going to explore. Together, we'll go further in understanding the cosmos. I'm Paul Edward, and I'll see you in the next video.